today we're going to take a look at one-step and multi-step equations. So let's go back with our one-step equations. M plus 4 6/10 is equal to 9. Okay, now this is a review. As we solve equations, remember, our objective is we want to isolate this m. I want this m to stand on this side alone. So that means I need to transform this 4 6/10 to the other side. We're going to use inverse operations. In other words, how do I undo addition? The inverse operation for addition is subtraction. So what I do to one side, I do to both sides because equations must balance. So I'm going to subtract 4 6/10 from both sides. What I do to one side, I do to both sides. Once you write a step down, simplify the step. 4 6/10 minus 4 6/10 gives me 0. That leaves me with the variable m on the left-hand side. That is what I was trying to do. Now on this side, I need to take 9 and subtract 4 6/10. So remember, in order to add or subtract decimals, we line the decimals up. The whole number 9 has a decimal here. Line the decimals up. I'm subtracting, so I need to add a 0. So 10 minus 6 gives me 4. And this is an 8 now, and 8 minus 4 gives me 4. So I get an answer of m is equal to 4 4/10. Example 2. If I had 8 2/10 x is equal to a negative 32 8/10. When we have a number and a variable right together, nothing between them, it indicates multiplication. The inverse operation for multiplication is division. So in order to solve, I'm going to use a fraction bar to show my division. So I'm going to divide both sides by 8 2/10. Well, these 8 2/10 will cancel, leaving me with x. Here I'm going to divide, and I'm going to set up the division for you, just to refresh your memory. I'm dividing a decimal by a decimal. The first thing I need to do is make this divisor a whole number. So I'm going to shift one place to my right. Then I'll go in my dividend, and I'm going to shift one place to my right, okay? 328 divided by 82 should be 4. So I put a 4 here. Let's multiply. 4 times 2 gives me 8. 4 times 8 gives me 32. A negative divided by a positive is a negative, so x is equal to a negative 4. Example 3. If I had x divided by 1 2/10 is equal to 15. That's a fraction bar. A fraction bar indicates division. The inverse operation for division is multiplication. So in order for this x to stand alone, I'm going to multiply both sides by 1 2/10. Here, as I simplify, the 1 2/10 on this side, they cancel. Now I'm about to multiply. 15 times 1 2/10. Multiply just like you do your whole numbers. 2 times 5 gives me 10. 2 times 1 is 1. 2 plus 1 gives me 3. 1 times 5 is 5. 1 times 1 is 1. When I add, I get a 0. I get an 8. I get a 1. I have one place to the right of the decimal. This number has a decimal here. I'm going to shift it one place to my left. And that gives me an 18 as an answer. Example 4. If I had n plus 2/7 is equal to a negative 3/7. Remember, fractions don't go away. I'm going to use the same properties that I just used. In order to undo addition, I subtract. So I'm going to subtract 2/7 from both sides. 2/7 minus 2/7 is 0, so I'm left with the variable n here. This 3/7 here is negative, that dash makes that negative, so I have a -3, a -2, that gives me a -5. So my answer is n is equal to a -5/7. Example 5. Y minus 1/6 is equal to 2/3. Again, the inverse operation for subtraction is addition. So I'm going to add 1/6 to both sides. That dash makes that 1/6 negative. Any number plus its opposite is 0. So I'm left with y. And remember, in order to add or subtract fractions, they have to have the same denominator. The least common denominator for 3 and 6 is 6. So I need to rewrite this 2/3 as 6. Ask yourself, 3 times what gives you 6? 2. So 2 times 2 gives you 4. This fraction remains the same. As I add my numerators, I get 5, 6. Never add or subtract denominators. Never add or subtract denominators. Example 6. If I had 5, 6x is equal to 5/8. Now the numerical coefficient here is a fraction. The quickest way to eliminate this 5, 6 is to multiply by its reciprocal. The reciprocal of 5, 6 is 6/5. So I'm going to multiply both sides by the reciprocal. Over here, that cancels, leaving me with x. Now we can use some cancellation on this problem. I can cancel out the 5s. Then 6 and 8 have a GCF of 2. Take 8, divide it by 2, I get 4. Take 6, divide it by 2, I get 3. So x is equal to 3/4. So that's a refresher for your one-step equations. Now we're going to take a look at multi-step equations. Again, we're going to solve example 1. If I had 8x plus 6 plus 3x minus 2 is equal to 37. The first thing I need to do is simplify what I have on the left-hand side because there are some like terms, such as 8x and 3x are like terms. So we need to combine those first. 8 plus 3 gives us 11, so we have 11x. Well, I have two constant terms. I can combine those. 6 minus 2 gives me 4, so that'd be plus 4. Now I have what I call a two-step equation. I need to isolate the 11x, so the 4 needs to be transformed to the other side. I see addition, the inverse operation is subtraction, so I'm going to subtract that 4 from both sides. 4 minus 4 gives me 0, so I'm left with 11x. 37 minus 4 gives me 33. Well, I have a number and a variable right together, nothing between them. This is one of my basic equations. That's multiplication. The inverse operation is division, so I'm dividing both sides by 11. Those 11s cancel, and 33 divided by 11 gives you 3. Example 2. 4 times the expression x minus 6 plus 7 is equal to 11. Now, you have been taught that you do what's inside parentheses first if possible. Well, x and 6, those are unlike terms. So we're going to clear the parentheses by using our distributive property, which allows me to take this 4, distribute it across both of these terms by using multiplication. So I'm going to multiply 4 times x, and 4 times x gives me 4x. And 4 times a negative 6 is a negative 24. So I have clear parentheses. Now, as I look at this, I notice that I have some constant terms that I need to combine. That dash makes that 24 a negative 24. That 7 is positive. So when I combine, I end up with a negative 17. Now I have a two-step equation. Transform the 17. I see subtraction. To undo it, I add. So I'm going to add that 17 to both sides. Any number plus its opposite is 0. So I'm left with a 4x. Here I get a 28. This indicates multiplication. Inverse is division. So I'm dividing both sides by 4. And x is equal to 7. Example 3. If I had 7x divided by 9 plus x over 2 minus 17 over 9 equals 2/3. Now, if you're uncomfortable with fractions, then we can eliminate these denominators, okay? By finding the least common denominator for 9, 2, and 3. And the least common denominator for 9, 2, and 3 is 18. So if I multiply everything up here by the least common denominator of 18, when I finish, I will not have any denominators left. I won't have any fractions. You have to treat everything the same. So I am multiplying everything up here by 18, which is my least common denominator. I make sure that you've treated everything the same. So I have multiplied each term by 18. Now I'll simplify each one of these. 9 goes into 18, 2. 2 times 7x gives me 14x. 2 goes into 18, 9, and 9 times x gives me 9x. 9 goes into 18, 2, and 2 times 17 gives me 34. And 3 goes into 18, 6, and 6 times 2 gives me 12. So as you see, by multiplying by the least common denominator, I don't have any fractions anymore. So as I look at this, I notice that 14x and 9x are like terms. So when I add 14x and 9x, I get 23x. Now I have a two-step equation. Transform the 34 by using addition, because the inverse operation for subtraction is addition. I end up with the 23x is equal to 12 plus 34 gives me 46. Again, this is multiplication. To undo multiplication, you divide. So I'm dividing both sides by 23. So I end up with x is equal to, and 46 divided by 23 gives you 2. Example 4. We're still solving. So if I had 4 times the expression m plus 2 plus 5m is equal to 26. Again, we're going to clear those parentheses. 4 times m gives us 4m. 4 times 2 gives us 8. This 4 doesn't have anything to do with that 5m, so we just keep the 5m. If you notice, there are some like terms on the left-hand side. You need to combine them. 4m plus 5m gives you 9m. Again, I have a two-step equation. To undo addition, I subtract, so I'll subtract 8 from both sides. 8 minus 8 is 0, that leaves you with 9m. 26 minus 8 gives you 18. This is multiplication, inverse is division, so I'm dividing both sides by 9. Those 9's cancel, leaving you with m, and 18 divided by 9 gives you 2. So that takes care of one-step equations and multi-step equations.